Here we are given with a problem where we need to find the direction of the body at any time t. That is, a body is projected with a speed u at an angle theta with the horizontal. So we know it is going to follow a parabolic path. And then at any time t, let us say that particle is somewhere here. So how do you find the direction of the body? We need to find the direction of the body at time t. That is, at time t, I have assumed the body to be over here. So how do you find the direction of velocity? By drawing a tangent to the path. Let us say this v makes some angle alpha with the base. I need to find alpha. What I have to find? I have to find the direction. Direction means angle made by the velocity with the horizontal, or you can also take vertical. Here I'm considering horizontal. Now, how do I find the angle made by the velocity vector with the horizontal? I'm going to resolve v into two components. I'm going to resolve v into two components. This is v. How did I find v? By drawing a tangent to the path. And I have assumed this as the angle alpha. So you can draw one horizontal component vx and one is vertical component vy. One is a vertical component vy, and I'll apply some trigonometry here. If this is vy, obviously this is also vy. So tan alpha is how much from the figure? Tan alpha is equal to vy divided by vx. So in order to find alpha, I have applied the trigonometry tan alpha, that is equal to opposite by adjacent, and that is vy by vx. So we know if this is vx and this is vy, I can resolve u also into two components, isn't it? I can resolve u also into two components. One is a ux, which is u cos theta, initial velocity along the x-axis. One is the initial velocity along the y-axis, which is nothing but u sine theta. We know vx and ux are same. We have seen in the analysis of the projectile, vx and ux are same because along the x-axis, there is no acceleration. Therefore, the velocity is going to be constant along the x-axis. So vx is same as what? Vx is same as ux. But vy will not be same as uy. Vy will not be same as uy because along the y-axis there is acceleration. Now, since along the y-axis acceleration is there, I can use the kinematic equation. So along the y-axis, I can use the kinematic equation because he's asking at time t. At time t, I need to find the velocity. So I can easily use the kinematic equation v equal to u plus at. And since we are applying particularly along the y-axis, I'll write it as vy equal to uy plus ay into t. So vy is vy. Uy is how much? Uy is nothing but u sine theta, which I can write it as uy for the time being, and it is in the upward direction. So it is going to be plus, but acceleration along the y-axis will be gravity, which is in the downward direction. So minus g into t. This is my vy that you can put it over here. So vy is going to be uy minus g into t. This is the formula for the angle made by the velocity vector with the horizontal at any time t.